All right, so our last section this week is 7.4. We've already touched on this section before, looking at trig identities. We're just going to kind of review a little bit of what we've done and go into a little bit more depth. Okay, so just a reminder of what an identity is. Okay? An identity is an equation that is always true, okay, for all appropriate values of the variable. Okay, so for example, if I did something like this, okay, what I'm going to write right now is an algebraic identity, not a trig identity, because I'm not going to do any trig here. Okay, if I put this as a problem in Algebra 1 and I said solve this equation, what do you get on the left when you distribute? 2x plus 2. And what do you get on the right when you combine like terms? 2x plus 2. You have the same thing on the left and right. So what that means is you can pick any value for x and this equation is true. Would it work if you plug in 5? Yep. 3? Yep. Negative 8.7? Yes. It's always true because it's an identity. Right? You can't pick a value for x that would make this false. It's impossible. Right? That's basically the same idea with a trig identity. It's an equation, but it has trig in it, like sine or cosine, and it's always true. Okay? You can't make it false. So the identities that I'm about to list, you should already be familiar with, and you already have them in your notes. Okay? If you need to copy them again, you can, but we've already done them in an earlier section. Okay, so the identities that we're studying are the fundamental identities, and there's 3 types. Okay. One is the reciprocal identities, and reciprocal basically means you flip something. Okay. So if you flip cosecant, you get sine. If you flip secant, you get cosine. If you flip cotangent, you get tangent. Let's see. Okay, cosecant. Well, you get that by flipping sine, and we already knew that, because that's how you have to type it into the calculator. Right? If you want to type in cosecant 1 over sine, that's how you do it. And the reason these are identities is because they're always true. Okay, 1 over cosecant equaling sine, that's not just true if x is 3, or if x is 7, or if x is 12. It's true for any value of x. As long as you didn't pick a value for x that caused you to divide by 0. That's a whole other issue. Okay? When you have a fraction, you can't plug in a number that would cause you to divide by 0. Okay, but besides that, these always work. Okay, we have the quotient identities. Does anybody remember the quotient identity for tangent? How you can rewrite tangent just using sines and cosines? Yeah, tangent is sine divided by cosine. Okay, that's a quotient identity. And if you can write tangent as sine over cosine, then you can write cotangent as cosine over sine. Okay, and then the last 3, I gave you these when we studied the first 8, but I said we're not going to do anything with them right now. Okay, well now we're gonna do something with them. Okay, they're the Pythagorean identities. Sine squared plus cosine squared equals 1. 1 plus tangent squared equals secant squared. And 1 plus cotangent squared equals cosecant squared. Now there are hundreds, probably thousands of identities. Okay? These are 11 identities. As far as identities that you really should know, these are the only real ones that you should know pretty quickly off the top of your head. The other hundreds or thousands of identities, if you ever need it, we just look it up. There's just too many other ones to remember. Okay, but these are what we call the fundamental, the very basic trig identities. If you take calculus in in the future or any kind of engineering, most calc books, if you flip right to the inside cover, either the front or the back, have all of these and tons more of identities. Any questions on those? And these are all in your book right on page 403. Okay, if you need them. In fact, I think I just took a picture of the page in the book and put it up there, basically. So as far as applications, really, we're not going to get into many of the applications with trig identities because the applications involve calculus. Okay? So what we're doing would be the first step in a calculus problem. Okay? We would take something like that, we would simplify it, and for us, that's where we stop. In calculus, you would then take that thing you simplified and do something with it, answer the question they were asking. Okay? But for us, we're not really going to take that extra step. Right, so there's a few basic tricks when you're trying to simplify something with trig identities. These tricks don't always work, but they're something that I usually try like 80% of the time. Okay? And this is one of the tricks I'm going to show you, is change everything to sines and cosines. Okay? And I say I'm only going to use it 80% of the time because it's like if you were teaching somebody to play chess. You know, you can teach them certain moves that might be good to do most of the time, but there might be a situation where that move is not a good move to make. All right? And it just depends. So the goal when you're changing things to sine and cosine is you're going to hope that something cancels out. As far as the identities on the test, most of them are going to be kind of in this category, more of an easier type problem. Okay. Like this one. This one's pretty easy. So let's try changing everything we have there to sines and cosines and hope we get something that cancels out. Right. Let's start with cotangent. From the identities on the other page, can anyone tell me how I can rewrite cotangent?
Cosine over sine.
Yep. You can write it as cosine over sine. Doesn't matter what they use for the variable. X, theta, that's just the variable. And how about cosecant?
1 over sine.
You could write that as 1 over sine. Now, when you divide two fractions that have the same denominator, what happens to those denominators?
You cancel.
Yeah, they cancel out. So I'm left with cosine divided by 1, which is just cosine. And that's the answer. Okay, so tomorrow when I'm out, this is a problem that if it was like this in the homework, the sub could read that answer. The answer is cosine theta. Some problems, I'll show you when we get to them, you can't really just read the answer because of the type of problem it is. But that's that one. Any questions on that? That's all we're really doing. But they do get harder. All right, let's try the same approach on this one. Can somebody else tell me cosecant? How can you rewrite cosecant? Yep, 1 over sine. That's cosecant. And Denver, how about tangent? There's two ways to rewrite it, but one way will help us here, and then one way really won't. Well, what are the two options? I'm hoping for you give me one that allows me to cancel something out.
Oh, probably sine over cosine.
Yeah, rewrite tangent as sine over cosine. Because now I'm multiplying fractions and I have the same thing in the top and the bottom. So what happens there? Yeah, the sign in the top and the sign in the bottom cancels. That only works with multiplication. Okay? If you have addition, you cannot cancel across an addition sign or subtraction. You can only cancel across a multiplication sign. Okay, that's important to remember. And now you're left with 1 over cosine. And what's 1 divided by cosine? Secant. Okay, so what we just did is we took something that was kind of complicated, 2 different trig expressions multiplied together, and we said it's equivalent to just doing this. This is a lot simpler than that. So now in calculus, the next step would be to do something with this, but now it's just 1 trig function rather than 2. Simpler. Okay. Any questions on that one? So these 2 problems said simplify and simplify. Another kind of problem you can have is verify. And verify is the kind of problem that somebody can't just read off the answer to you. Because, I'm going to go back to it, but with a verify, this is what you're starting with. This is what you're ending with. Okay? You already have the last step of the problem. You need to fill in all the steps in the middle. How do you turn this into that? What are all the steps? Somehow all this stuff just cancels out. Okay? So that's the difference with a verify. You already know where to start, you know where to stop, fill in the middle. Simplify, you don't really know what the end is going to be. They just tell you where to start. Okay, so as we go through, we'll practice some problems that are simplify, and then we'll do some other ones that are verify. So when they ask you to verify, since they're going to give you what to start with and what to end with, you really have 2 choices how you want to do the problem. You can either take what's on the left and turn it into what's on the right, or take what's on the right and turn it into what's on the left. You can do it either way. My suggestion, though, is to always start with the side that looks more complicated. It's a lot easier to take something that's complicated and simplify it than it is to take something that's simplified and make it more complicated. Okay. When something's complicated, you can rewrite it and cancel things out. When something's already simplified, it's a lot harder to make it look more complicated. That's just not normally how we do things. So take the complicated side and make it look simpler. If you can't tell which side is more complicated, then chances are it doesn't really matter which side you start with. Okay, so when I look at a problem like example 4, I think the right side is more complicated. It has a fraction, it has addition. The left side is just a single trig function. Okay, now sometimes people try to work with both sides at the same time, but I think that's just going to be confusing. So I wouldn't do this. It's a suggestion in the book. But then you're trying to do 2 things at the same time, and sometimes that messes people up. So I would stick with that. All right, so the first trick I showed you was changing everything to sines and cosines. A lot of times that works out nice, but sometimes you want to try something a little different. Okay, and another trick for working with trig identities is to rewrite with a common denominator. Okay, a lot of times you use this trick when you have addition or subtraction and you have fractions. Right, so if you had something with just numbers, and I wanted to add those up, I need to find the common denominator. What's the common denominator between 3 and 4? 12. So the easiest way to do a problem like this is just take one of your denominators, multiply it by the other one. Okay? So I would take the 3 and multiply it by the 4. But if you multiply the bottom of the fraction by 4, what else do you have to multiply by 4? The top. And now I'm going to take the 4, multiply by the 3, but if I do it in the bottom, I have to do it in the top. And now I could do this problem and find the answer. Well, we're going to do the same thing with trig, except you're not going to have numbers you can simplify. You're just going to take each denominator and multiply it by the other one. That's how you find the common denominator. Okay, but it's going to be with a word, not a number, but exactly the same idea. Okay. And just looking at this problem, it doesn't look like that idea is going to come up at all because I don't even have fractions. If you don't have fractions, you definitely don't have common denominator. You don't have to worry about denominators. But as we go through this problem, you might see all of a sudden fractions pop up, okay, as we start to do stuff. So keep that in mind. Right. Any thoughts what property I could use here? It's a property we use all the time with numbers.
Distributive.
Yeah, distributive. We're going to do the same thing with the word sine. So you're going to multiply sine to cotangent and to tangent. And don't do anything else yet. So you have sine times cotangent plus sine times tangent. Okay, I still don't have any fractions. So in my head, I'm not thinking I should be worrying about common denominators yet. There's no fractions. So there is one other trick I have. And what's the first trick that we learned?
Change everything.
Let's change everything that's not a sine or a cosine into a sine or cosine. Okay. Austin, how can I rewrite cotangent? Well, I'm trying to write it in a way that I'm going to hope cancels out something.
So cosine over sine.
Yep, I would write it as cosine over sine. Okay, that's good. And now the second one, we have sine times. Ryan, how do I write tangent? That would be cotangent. No, it already is tangent over 1. If you want to pretend there's a 1 there, you can. So it's already over 1. Yep. Sine over cosine. Now, in my head, I'm already starting to think, okay, I get some fractions here, so maybe common denominators is going to come up now. What happens with the first term? Yeah, if you want to think of it as sine over 1, that's fine. Sine in the top, sine in the bottom, cancels. So what's on the left side of the plus sign? Cosine. Now, on the right side, that doesn't happen. I have cosine in the bottom. And what do I have in the top? It's sine times sine. It's like x times x. It's sine squared, yeah, or x squared, however you want to think of that. Sine squared. Okay. Now, there's no denominator here, but I could put in a 1. Now, I'm thinking to use that trick I just showed you. I have two fractions with different denominators. I can't change things to sine and cosine. I already did that. So the only other trick I can try, and hopefully something nice happens, is to find a common denominator. Okay. What's going to be my common denominator?
Cosine.
Cosine. The common denominator is always the product of the two that you have. I have a 1 and I have a cosine. So cosine is my common denominator. What do I have to do to the fraction on the right to make it have a denominator of cosine? Okay, so what does that really mean?
It just makes it sine squared x.
Yeah, Yeah, it stays the same. The fraction on the right already has a denominator of cosine, so you don't need to change it. It's kind of like if you were adding, just trying to make up an example, 2/3 plus 7/6. The common denominator is 6. This one already has a 6. You don't need to change it. It's just this one you need to change. All right, so let's look at what we've got. What would we have to multiply 1 by to make it the common denominator? Cosine. And if we do it on the bottom, where else do I have to do it? On the top. What's cosine times cosine? Cosine squared. Not sure why all of a sudden I put in an X in. We were using thetas for the whole problem, so we should really stick with the same letter the whole time. All right, so now I'm at this step. I can't change anything to sines and cosines. I already did that. Can't find a common denominator. I already have one. So now there's something here we need to recognize. That's an identity. And it's not written exactly the way I gave it to you, but it's extremely close. Does anybody see anything? Yeah? Yeah, look at this top part. Cosine squared plus sine squared. Cosine squared plus sine squared. It's not exactly the same, but you got to look for things like that. It could be written a little differently. If you add those two things together, what does that identity say you get? 1. So all of this cancels out and turns into a 1. If you don't see that, you're stuck. So you have to recognize that sine squared plus cosine squared is 1. And now we're just left with 1 over cosine. And what's 1 over cosine? Secant. So we took something that originally had 3 different trig functions in it with a distributive property and a plus sign, and we simplified that whole thing to just one word, secant. So now if we had to do any more steps, this is very easy to work with. Much, much easier than trying to work with this. Okay, so that's kind of a harder one. Okay, it's got a lot of stuff in it. Any questions on that one? Okay, and the other thing, I'm not going to give you any problems on the test that you haven't seen a trick for. So it's not like you're going to get to a problem on the test and have to try something brand new you've never done. Okay, so all the problems on the test are going to involve the tricks I'm showing you right now. All right, so this is our first verify. Okay, so verify means you can start with either side, make it look like the other. My suggestion was to start with what side? The more complicated side, yeah. Okay, so I'm going to take secant over tangent plus cotangent, and I'm going to work with that until I'm done and I finally get an answer of sine. Okay, that's what I should get when I simplify it. Okay, so we're starting with what's on the right, we're going to finish with what's on the left. Now, even as I go through identities, what's nice sometimes is I teach the same thing back to back. So the first time I teach it, I don't find the best way to do it, and then the second time I can fix it. Well, with you guys, this is the only time I teach it. So sometimes I don't always find the best way to do it right away, okay? Because there's tons of ways you can do it. But the goal is to try to find the simplest way, if you can. All right. So what's a trick we could try here? Yeah, let's try changing things to sines and cosines, and hopefully we get something that cancels out. So secant is 1 over cosine. Tangent is,
Sine over cosine.
yeah, there's two ways you can do it. You can write it as sine over cosine, or you can write it as 1 over cotangent. Let me just think for 1 second about which way I think is better. If you did it as 1 over cotangent, then we could end up with, let's see, 1 plus cotangent squared. Is that a Pythagorean identity? Let's see. It is. 1 plus cotangent squared is cosecant squared. So that's one way I could do it. Okay, so in my head, I'm kind of thinking about different ways to do it before I actually do it, which is kind of hard when you're starting out. But the other way I could do it would be sine over cosine plus cosine over 1. Cosine over sine, sorry. And that would give me a cosine sine with a 1. Let's do it that way. Again, it's your choice, but it's kind of tough to figure out which way is always going to be better. So let's try writing everything as sines and cosines. Okay, so I've got sine over cosine plus cosine over sine. Any question on that stuff? All right, the top I'm going to kind of ignore for a while. I'm not really going to do anything with it. I'm just going to work with the bottom because something very nice is going to happen with that. Right? So I'm just going to kind of keep the top where it is. And now let's get a common denominator. What's the common denominator of just the stuff in the bottom? Cosine, sine. It's the product of the two denominators you have. Okay? Ignore what's in the top. Just leave it. It's cosine times sine. So cosine times sine. Now, what is this denominator missing to make it the common denominator? It's missing a sine. So let's put in a sine. Now, what is this denominator missing to make it? It's missing the cosine. So let's put in a cosine. And remember, whatever you do to the bottom, you have to do to the top. So, sine times cosine is our common denominator. What's sine times sine?
Sine squared.
Sine squared. And what's cosine times cosine?
It's cosine.
Cosine squared. Right. Sine squared plus cosine squared, all of that is going to cancel out and turn into a 1. Okay, so again, the top, I'm just going to leave it. I'm not going to do anything with the top till the end of the problem. Okay, so now sine squared plus cosine squared is 1 divided by cosine times sine. Now, we've got a fraction divided by a fraction. So if you had a fraction divided by a fraction, how do you do that? Don't get stuck on the 5th grade stuff. How do you divide two fractions?
Flip the second one.
Oh, yes.
Yeah. Keep the top the same, multiply by the reciprocal of what's in the bottom. Okay? So let's do that here. Keep the top the same. What's the reciprocal of the bottom?
Cosine times sine.
Cosine times sine over 1. Now look what happened. You're multiplying fractions, and you have the same thing in the top and the bottom. So what happens? The cosines cancel. What else is also in the top and bottom that's the same? The 1s. What's the only thing I'm left with? I'm left with sine, which is exactly what I was supposed to get. Now, I would say, I think we picked a pretty good way to do it. I don't know if the other way could have been a little shorter. That's a harder one. Okay, so that's probably as hard as one that you would ever see on the test. Nothing harder than that. Okay, but it involved changing to sines and cosines, finding a common denominator, a Pythagorean identity, and that was basically it. And then just using basic rules of arithmetic, dividing two fractions. Okay, remember, anything you can do with numbers, you can do with what we're learning right now. Flipping, multiply by the reciprocal, distributive property, all that stuff still works. Okay, so that's a verified, and that's why I can't really have a sub read off the answer, because this is all the answer. Okay, it's not just what did you end with. We already knew what we were supposed to end with. We already knew what to start with. How do you get from the beginning to the end? That's the work. Okay, that's the answer. So if somebody has a question on a problem like that tomorrow, and somebody thinks they got it, you could come up and show your work, and maybe that would help it make sense for someone. Okay. All right, and the last trick that'll come up sometimes when we're working with identities, in addition to changing sines and cosines and finding a common denominator, is to use what's called a conjugate, multiplying the top and bottom of a fraction by a conjugate. Okay, so let me show you what the conjugate is. We did this before with complex numbers. The conjugate of 1 plus sign is 1 minus sign. All you do is change the sign of what's in the middle. If you had 3 minus cosine, the conjugate would be 3 plus cosine. So sometimes just by multiplying by the conjugate, it causes stuff to cancel out. And the reason why that works is think of something like this. These are conjugates. X minus 2, x plus 2. When you multiply them together, you get x squared. What's x times 2? And what's x times negative 2? There's your canceling. Okay? Positive 2x, negative 2x. The same kind of canceling can happen with sines and cosines. And then, of course, you'd have to do negative 2 times 2. Okay, so that's the third trick, multiplying by conjugates. Okay, example of that one and that one are pretty much the same. Let's do this one. Now, this is a verify. So you can start with what's on the left, or you can start with what's on the right. Which side looks more complicated?
The left. That's subtraction at the bottom.
All right, well, the right has an addition in the top.
Yeah, but, well, and you could pretty much argue this one.
Yeah, I'd say they're pretty much the same complexity on each side.
Right.
So it doesn't matter which side you start with. They both have a fraction, they both have addition or subtraction, they both have sines and cosines. They're pretty much the same. So which side do you guys want to start with, left or right?
So,
Left. So we're going to start here, and we're going to end here. The goal is to show how to do that. So let's take this. And what I do is I run through all the different tricks in my head. Could I change things to sines and cosines? Why not?
They're already percent.
It already is. What are you going to change to sine and cosine? Sine and cosine? Yeah, it's not going to work. Common denominator. There already is one. You have one big fraction. You don't have two separate fractions with different things here and here. Okay, it's already one fraction. So the only other trick I have is to try the conjugate, and this is a perfect problem for trying a conjugate because it's a number plus or minus a trig function. number plus or minus trig function. Now, I didn't say the conjugate had to be in the bottom. Had you guys told me to start with the right side, I would have been dealing with the top. But in this case, I'm going to deal with the bottom. So, we're going to multiply top and bottom by, what's the conjugate of 1 minus sign? 1 plus sign. I'm also using the letter t now instead of theta. That doesn't matter. Now, in the top, I'm not going to do it out. Yes, it is a distributive property. And this is where just knowing or having practice with identities is helpful, just experience. I'm not going to do this out, and you'll see why in the next step. Okay, so at this point, I try to make like an analogy with chess. Sometimes you make a move now because you already know what you want to happen, like 2 or 3 moves later. That's like chess. Well, it's the same idea here. I'm doing something now because I already know something that's going to happen 2 or 3 moves from now. How do I know that? Just experience. That's all. So leave the top as cosine times 1 plus sine. And I'm not saying if you did the distributive property out here, you could still solve the problem. It's just going to make it harder. I'm trying to keep it easier. Okay, now let's do out what's in the bottom. Okay. What's 1 times 1? 1. What's 1 times sine? And what's 1 times negative sine? There's your canceling, just like I explained before. 1 times positive sine, 1 times negative sine. That's gone. What's a negative times a positive? Negative. And then sine times sine? Sine squared. Now, here, we have to recognize something. Does this bottom kind of look like something we've done before? What does it kind of look like, but it's rearranged a little bit? It's an identity we used today a couple times. The Pythagorean identity. Sine squared plus cosine squared equals 1. Well, watch what happens if I do this. I'm going to move this to the other side. It's not a new identity. It's the same identity, just moving something around. How would you move that to the other side? You'd subtract it. And you would subtract it. So I get cosine squared equals 1 minus sine squared. So this, 1 minus sine squared, is just cosine squared. So that whole bottom turns into just cosine squared. And now look what's in the top. Cosine times 1 plus sine. What do the top and the bottom both have in common? Yeah, there's 1 cosine in the top. How many in the bottom? 2. So they each have 1 in common. 1 in the top, 1 in the bottom. What's left in the top now? 1 plus sine is in the top. 1 plus sine. What's in the bottom? Cosine. That's exactly what I was supposed to get. Okay, so that's the trick with the conjugate. Okay, and it definitely takes a little bit of practice to get used to. That's why tomorrow is a review day to basically practice all these kinds of problems. All right, so I think yeah, that's a good place to stop. Those are just extra practice ones that we don't even need to do. All right, so on 407, 4 through 8, those are ones tomorrow that the answers can be read off. Those are simplified. 11 and 12, the answers can be read off. 21 to 25, or 27, those are verified. The answer can't really be read off. It needs to be shown to you how to do it. Okay, make sure you check for a review video. It should already be on your class posted. Remember, the one question you don't need to know how to do is that inverse sine domain and range question. It's at like minute 5 in the video. Okay, so during class tomorrow, you'll go over the homework the best you can with the sub. I've got a worksheet to get ready for the test, and then another worksheet just on trig identities.